Hello everyone, today I'm going to be going over the TARC competition rules for 2022 and also doing an introduction of Openrocket. So for this year's competition, the maximum weight of your rocket is 650 grams, while the minimum weight is 650 millimeters or 65 centimeters. Each rocket needs to use two different diameter body tubes, and each tube must be at least 6 inches long. Unfortunately, the rules kind of mix metric and customary units, so that's just something you have to deal with. So all of the portion of the rockets needs to be connected with some sort of tether. We're going to be using a shock cord. You also need a recovery method, which is a parachute. The rocket must contain and completely enclose two eggs. So the eggs will have the weight between 55 and 61 grams, and the length of the eggs will be between 56 to 59 millimeters. Your eggs are going to be flown sideways, so the long axis of the egg is perpendicular to the long axis of the rocket body, which looks something like this. Your flight duration goal is a range of 41 to 44 seconds, and the height you want to reach is 835 feet. You probably will need a BT80 and BT70 body tube because each body tube needs to have different diameters, and you probably will need to use transitions. And since more eggs are being flown this year than last year, we probably are also using F-class motors. So now we use Openrocket to design our rockets, so you can get the links to download Openrocket either on our club website at TJHSST Aerospace and click on Resources, Files, and Links. Here you're going to find a link to download Openrocket, or you can go to openrocket.info. Unfortunately, it doesn't work on Mac, so you can either try and build this from source code, get a VM on your Mac. I've tried various solutions and have not been worked out how to get it to work on Mac yet. Hello, now we're going to start building our rocket. So, first you want a body tube for your rocket, so you just click here to get the body tube. You want to select one of the presets from the database. Since we're using two different stages this year and you have to put your egg lengthwise, we're going to be using a BT70 body tube, which is somewhere. Where's the BT70 body tube? Oh my god, where is it? I am currently in the process of looking for the BT70. Yay, I found it. It's here. Click OK. You want to change the material to make sure it's cardboard. And you can change the length like this, either using the scroller or using the numbers over here. This body tube is a bit, and you can change it to inches if you don't feel comfortable using metric. I'm just going to make my upper body tube rough, maybe 9 inches. And now I need a nose cone, so I'm just going to select nose cone. But this nose cone is in the wrong location, so I'm just going to drag it up here. And to continue editing it, you can just double click on that item. I'm going to change it to an ellipsoid nose cone, and I'm going to use inches since I like inches. What are these units? You generally don't want to change these settings, so just leave the nose cone as it is. Maybe we can make this 5 inches is a bit long for a nose cone though, so I'm going to change it 3. Then I'm going to click close. But the nose cone, you'll probably be given a nose cone and you can't really change the size of that. So next, we're going to have to add a transition because we need we have two body tubes for our rocket. I'm going to add the transition here, and then I'm going to add the second body tube. This one is a BT80. Generally, when you're designing your rocket, the bottom part should be larger than the top part of the rocket for stability. I'm going to click OK. As before, I'm going to change the length of my rocket. Maybe 34 centimeters. So let's make this It also needs to be slightly longer, so I'm just going to make it 14 inches. Next, we're going to have to add the mass components. The masses, the eggs will be up here, so you can just use a mass component to represent your egg. So the mass object, you're just going to put mass component. Doesn't matter what it is, just put unspecified. You can increase the mass of the egg. I think the egg is 55 grams. And the egg is going to be horizontal, so it's going to be fat on the sides. Maybe this large. Maybe make it a bit wider. So the egg would roughly be like that. Probably want to move it a bit further down. The egg will probably be here somewhere. Click close. Then I'm going to, and you can actually name these two. So instead of unspecified, I'm going to call it egg 1. Close. Okay, now I'm going to add the second egg. So I will click on this to make sure it's selected. And add the second egg. Let's say the second egg is 56 grams. Slightly heavier than the other egg. So again, I'm going to make it slightly larger and maybe increase this a bit. Click, and then I'm going to move it slightly down. Maybe here. Yeah, my egg would probably be there. And then I'm going to click close. And your rocket also needs fins. You can select any of these fins, but you generally don't want your fins to be very complex. So I'm just going to select trapezoidal fins. And you can play with these settings to change the shape of the fins. You can either have 3 fins or 4 fins. I'm going to keep mine at 3. And I'm going to make sure the material is not cardboard. We use plywood for our fins. And you can play with these settings. So root cord makes it shorter. And fin can't. You don't want to touch fin can't. I'm going to reset this to 0 as it was before. Interesting. I'm going to continue working on the fins. And maybe I can make it a bit taller. 3 centimeters seems a bit short. I'm going to change this to inches. I'm going to make it my fins slightly taller, maybe a bit wider. And I'm going to change the length of the tick forward. Don't touch these two. And just play with the settings down here. Maybe I can change the sweep angle a bit. Just play around with this as necessary. You probably want to move this. You might want to move this maybe 0.1 centimeters up. Oops. Since you're moving it up, it's negative 0.1 centimeters. So there are the fins for my rocket. Your rocket should also have a shock cord, which is the tether. The shock cord is just an elastic cord. Generally, it's 1.5 times the length of your rocket. So I'm going to make this roughly 105. You also need a recovery method, which is the parachute. For the parachute, don't touch any of the others. You can just change the diameter. We have 12-inch, 18-inch, and 24-inch parachutes, I think. I'm going to change mine to inches. I'm going to make it 18 inches. Why not? And the other mass components include... Oh, let's rename this Egg 2. The other mass components would be an altimeter, but you can add that as necessary. Next, we're going to need an engine mount. So I'm just going to add an inner tube. It's called a motor mount. And you want to select a preset from database. It's a BT50. I'm looking for the BT50 body tube right now. Actually, this is my second time making this video since the first time I was recording a blank Chrome tab. I hope this time works. Where's the BT50? Oh my god, where are you, BT50? Found it. I found the BT50. I'm going to click OK. I want to make sure that this is not spiral glassine, whatever that is, and it is cardboard. I'm probably going to reduce the length. Whoops, let me select the BT50 again to reset that. I did not mean to touch that setting. You don't want to change the diameters of your body tubes. Can't recall from... Where are you? Found the BT50. Yay, the length isn't bad anymore. I'm going to make a cardboard. I'm going to change the length here, this scroller down here. Aside from this, you probably also want centering rings to keep your BT50 body tube in place. Centering rings are made out of wood, probably plywood. You want to make sure that it's around your motor mount. Add another one, centering ring. And I'm going to make this motor mount a motor component. And the stability you generally want to be between 1.5 and 2. Too stable and your rocket's just going to stay there in the air when the wind blows at it, perpendicular to it. And 2, low the stability, your rocket is just going to turn, and that's bad. So for our motors, I think we're using F motors this year because we need to fly more weight, either that or we're going to continue using E motors. I'm going to pretend that we're using F motors this year. So I'm going to click New Configuration, select Motor. Let's find the F class motors. Let's say we're using an F32. This is entirely arbitrary. I'm guessing we might be using F29s, F35s maybe. But I'm going to pretend that we're using an F32 motor. I'm going to click OK. I probably want to make my body tube a bit longer. No, sorry. I probably want to make my body motor mount a bit longer, so I'm going to fit the rocket itself. No, sorry, the motor itself. I'm going to click close. Stability is a bit low, so I'm going to try and get it in the 1.5 range. You can do this by making your rocket longer, and that's good enough. The rest is for you to figure out, and to simulate launches, you would just go to Flight Simulations, and you would click New Simulation. You generally don't change any of these settings, and you can click Simulate and plot, and there you have it. Your your rocket. Generally, you want the parachute to deploy roughly at the apogee or the highest point of your rocket. The ejection charge is the thing that burns before it starts burning the actual engine, and remember this year our target time is 41:44 seconds. Generally, when you're doing simulations, you want your simulated height to be above, roughly 100 feet above the actual height. Clearly this one is too high. I don't know why. So looking at this data, it's clearly too high. So so you generally want the impact speed to be less than 10 meters per second, and hopefully this was enough to help you start designing your own rocket. I want our club to do really well this year. Good luck, everyone.